Today's lesson is lesson 3.3, rate of change and slope. We've already talked about rate of change in a table to identify linear versus nonlinear functions, but we're going to go a little bit more in depth. The rate of change is the ratio that describes how much one quantity changes with respect to another. If we recall from middle school, the word ratio implies a comparison, and we can typically do that comparison as a fraction. So we're going to be writing the rate of change as a fraction that describes how much one quantity changes with respect to another. The two quantities we're going to be comparing are our x values and our y values. So if our x is our independent variable and y is the dependent variable, then our rate of change we are going to compare is the change in y over the change in x. So we're always going to put the change in y in the numerator over the change in x in the denominator. So the rate of change, remember, is constant for a linear function. So that means every single rate of change between every single set of x and y values has to be constant to be a linear function. And this means that each rate of change is the same between any pair of points. So if we're going to find the rate of change, it says find the rate of change between each interval to determine if the function is linear. So to find our rate of change is a comparison or a ratio of our change in y values, how is y changing, compared to how is x changing. So if I look at my first example, time is always your independent variable and distance is going to be our independent. So I want to look at my change in y's first. So if I'm looking at my change in y's, remember change in means what's happening between 76 to 152. And in this case, I'm adding 76. So my change in y is a positive 76. And my change in x, to get from 2 to 4, I have added 2. So my change in x would be 2. And then I'm going to always simplify my fraction if possible. So 76 divided by 2 is going to be 38. So my rate of change between those first two ordered pairs is 38. Then I have to do that again. I'm going to look at my change in y's. What am I doing from 152 to 228? My change in y. And in this case, I'm adding 76. So my change in y is a positive 76. And then I'm going to put that over my change in x. And in this case, to get from 4 to 6, I'm adding 2 again. So if we notice, 76 divided by 2 is 38. Both rates of change were 38. And so since they were the same, since the rates of change were the same, we would say that this is a linear function. So we're going to say linear because the rates of change were constant. Now, I can look at B, which is a graph, and the graph, I can always tell from a graph whether something's linear if it graphed into a straight line or not. Obviously, part B, it does not graph into a straight line, so we know this is not a linear function. So I know that my final answer should be not linear. However, it does ask us to find the rate of change between each set of points. So we do need to do that. So we're going to start with the first ordered pair. And then we're saying what's the rate of change to get to that second ordered pair. So remember, our rate of change is always going to be change in y. How are my y values changing to how are my x values changing? So if I look at this, my y values come from the y-axis. So I have to look at this first ordered pair and ask, what is my y value? And it actually tells you, because this graph is actually kind of hard to read because your ordered pairs are not on nice pretty points. So it tells us that our y value is at 7. And then From 7, I go all the way up to 8.9. So how is y changing? I went from 7 to 8.9. It increased by 1.9. Then I'm going to look at my change in x. So my change in x, I have to look at my x-axis. I started at the year 2002. I ended at the year 2004. So what's the difference or the change from 2002 to 2004? That would be 2 years. And then we're going to divide that. So 1.9 divided by 2 would be 0.95. So my rate of change between the first two ordered pairs is 0.95. Then I'm going to find the rate of change between the next two ordered pairs. So I'm going to start again by finding my change in y. So this time I started at y value of 8.9 and I went to a y value of 12.1. So I have to ask myself, what is the change in y? What's happening to get from 8.9 to 12.1? And that would be a 3 2/10, 3.2. I went up by 3.2. Then my change in x, I'm going to do the same thing. I started at 2004 and I went to 2006. So I increased by 2 years. And if I divide 3.2 divided by 2, I end up with 1.6. So notice those two rates of change are different. My first rate of change was 0.95 and my second rate of change was 1.6. Since my rates of change are different, this is not linear. So it would be not linear. So we would say nonlinear. Because the rates of change are different. Because we have done rates of change before today, we are going to skip examples C and D today in your notes, so you are not responsible for C or D. So another word for rate of change is slope. Slope should sound familiar from 8th grade or from middle school. Slope, so the slope of a non-vertical line is the ratio, so we're still talking about a fraction, of the rise to the run. So it's really no different than finding change in y over change in x. The y values tell us how to rise. Do we go up or down? And then the run tells us whether to go left or right. So when we find slope, the rise, how we move up and down, goes in the numerator, and then we run in the denominator. How do we move left and right? So really, our change in y, if you think about the y values tell you how to go up and down, so that's why we call it the rise. And then your change in x, if you think about your x values, how is x changing? The x value tells you to go left or right, which was why we call it the run. We run from left to right. Now, the word change in, which that's what that little triangle means. It just means change in. If we're talking about finding the change in something, so if I told you that it was 60 degrees outside, and then by lunchtime it was 70 degrees outside, find the change in temperature, you would tell me 10 degrees. And the way you found that was by subtraction. So if we're talking about numeric numbers and giving you ordered pairs, change in means you're subtracting the y values over subtracting the x values. So we're going to do some examples with both of those. So we're going to start with what types of slope do we have? Well, we read left to right. So since we read left to right, we should already know what type of slope we're going to have. In this first picture, you will notice as we read left to right, we go uphill. If our line is going uphill, we should have a positive slope. And the next one, if we read left to right, we're going downhill. If we're going downhill, you should have a negative slope. Now, I can walk uphill, I can walk downhill, I can also walk a flat line. If I can walk a flat line, that means I can actually find the slope. This would have a 0 slope because I'm not going uphill or downhill. It is a flat line. However, I am not Spider-Man, so I cannot walk up a wall. So when we have a vertical line, since I cannot walk a vertical line without some sort of assistance, we say that slope is undefined. And a lot of times you'll see the undefined is a 0 with a slash through it. So those are our 4 types of slope that we have. All right, so we're going to find the slope of the line that passes through each pair of points. In order to do this, we do have to recall that our rate of change or slope is change in y over the change in x. And I'm going to color code this a little bit better so that you understand where these numbers are coming from. Our change in y. So if we're talking about the change in our y values, that means I need to figure out how are my y values and my ordered pair changing. My y values are 5 and 0. So if I'm talking about change in, remember that means to subtract. So I'm going to choose a y value to start with. I'm going to choose 5. So I'm going to take 5 minus 0. So the change in my y values is 5 because 5 minus 0 is 5. Now, if I started with the 5, I have to start with the matching x value when I find my change in x. The matching x value would be 1, and then I'm going to subtract, and notice this is a negative 2. So I'm going to have to take 1 minus, not just 2, 1 minus a negative 2. And remember, minus a negative really means to add a positive. So we're really looking at 3. So my rate of change is equivalent to 5/3. 5/3. You do not have to write it as a mixed number or a decimal. You just have to make sure it's in simplest form. I do want to call out or let you notice that you can go the opposite direction and you will get the same slope. So if you chose to start with the 0 first and you did 0 minus 5, if we did 0 minus 5 for my change in y, 0 minus 5 would be a negative 5. If I started with the 0, that means I have to start with the matching x value, which is the negative 2. So I'd have to take negative 2 minus 1, which is negative 3. And then now you'll see that you have a negative over a negative, but a negative over a negative makes a positive. So no matter which way you start with the first order pair or the second order pair, your rate of change should be the same. So if we look at example B, we're going to start always, the change in y goes in the numerator. So if I'm looking at my change in y, I'm asking how are my y values changing, which means I'm going to be subtracting my y values. So I'm going to start with 5, which means I'm going to take 5 minus 2. So we have 5 minus 2, which gives me 3. And then if I start with the 5, I have to start with the matching x value, which is also a 5. And I'm going to take 5 minus, and then that is a negative 3. So remember, minus a negative really means to add a positive. So we are looking at a slope of 3/8. 3/8. So my rate of change or slope is 3/8. For letter C, we're going to do the same thing. I'm going to find my change in y. So how are my y values changing? And you can choose to start with any one you want. I'm going to choose to start with the y value of -3. So I'm going to be taking -3 minus 4. So -3 minus 4, which would be a -7. If I started with the y value of -3, that means I have to start with the x value of -2. And I have to take -2 minus a -2. Remember, minus a negative really means to add a positive, and -2 plus 2 is really 0. I cannot divide by 0. If you take -7 divided by 0 on your calculator, it's going to tell you an error. That's because you cannot take 7 of something and divide it into 0 groups. You have to have at least one group. So this actually has an undefined slope. So we automatically know what that line would look like. It has an undefined slope, which means it's a vertical line because we cannot walk up a wall. And then last but not least, for the ordered pairs, we are going to do letter D. So my change in y over my change in x. So I'm going to find my change in y first. So I'm going to select my y value that I want to start with, which is going to be, I'm going to choose 5. So I'm going to take 5 minus 5. Well, 5 minus 5 is obviously 0. And then since I started with the 5 that's on the right, I'm going to start with the -4 because that's the matching x value I started with. And I'm going to take -4 minus 3, which would be -7. This time our zero's in the numerator. I can take 0 divided by 7. 0 divided by 7 is 0, so my rate of change is 0. So a little hint here. If you have 0 in the denominator, that is no way. You cannot do it. But if your 0 is in the numerator, that is okay. That will give you 0. And last but not least, finding slope from a graph. So when we find slope from a graph, we simply just get to count the change in y over the change in x, which is really simple because we're just counting really how are we rising over how are we running. So how are we moving up and down versus how are we moving left and right. So you're going to choose an ordered pair to start with. I'm going to choose this ordered pair. And to get to my next ordered pair, which is 4, 2, I would have to go up 3 units. So up would be my rise or my change in y. So my change in y is 3. And then from there, I'd have to go right, and I would go right 6. So my run is a positive 6. And then we know that we can reduce 3 6 to 1/2. And so my slope is 1/2. If you chose to go the opposite direction, which you can choose to start at the ordered pair 4, 2 and go to -2, -1. But if you go that way, your change in y, you went down 3, which would be negative. And then from there, you would not go right 6, you would go left 6. So your change in x is also negative, and we know a negative over a negative is a positive. So you will get the same answer no matter which way you decide to do that. You just need to watch your signs. And notice, our line should be a positive slope because it's going uphill from left to right. So you can even start at the beginning and say, okay, this line is going downhill from left to right, so I know my slope should be negative. If you don't get a negative slope, then you made a mistake. All right, so we're going to start with one of our ordered pairs. I'm going to start with -2, 4. And I ask myself, do I have to, on my change in y, do I have to go up or down. So change in y is always up or down because I'm going to rise over my run. So I rise or run over the run. So I have to rise a negative 1, 2, 3, 4, 5, 6. I went down 6. So my change in y is negative 6. So I have negative 6 over, and then from there I have to go right 2. So my change in x, or my run, is a positive 2. And then negative 6 divided by a positive 2 would be a negative 3. So my slope is negative 3. Please do not tell me negative 3 over 1. Negative 3 over 1 is just negative 3. So that's how we would find slope from a graph.